Okay, so in this particular problem we have a fan of mass 380 kilograms with negligible damping that due to some imbalance in the machinery which is measured, it says the rotating imbalance is 0.15 kilogram meters. I think that's actually the mass times the eccentricity. No. Yeah, that's the off center, the imbalanced mass times the eccentricity. That's right. Whereas this is the total mass of the machine. Okay, so this is this mass and this mass are two different things. This is a much smaller mass. This is the part that's out of whack, so to speak. Alright, so we want to find the amplitude of vibration at this, oh, there should be a 0 here, 1750 RPM. Let's start with our amplitude equation and see what we need. Our amplitude equals, okay, in this case we got amplitude for eccentricity is me over the net mass times omega over omega n squared over the absolute value of 1 minus omega over omega n squared. Alright, let's multiply that. Okay, so we've got me, check. We've got m, check. We don't have omega n, but we do have omega, check. Kind of. We have it, but it's in the wrong units. We've got 1750 cycles per minute. Okay, so we want to multiply this by we got 2 pi radians per revolution over 60 seconds per minute. The minutes would be up here, so they cancel out with those minutes. Here the radians per cycle, cycles on the bottom, so that would cancel out with that. So this comes out to be 183.26 radians per second. Alright, so we've got omega. Now all we need is omega n. Alright? Omega n is equal to the square root of k over normally it's k over m, but in this particular, I don't know where he's coming up with this stuff. This is like voodoo black magic, as he puts it. You know, I can understand with the rotational stuff, you know, supplementing in the k torsional over the what is it, the moment of inertia or whatever. But here he has it being g, the acceleration g over the delta yg is what I called it. He called it I don't know, is that a delta? I feel like that's a lowercase delta, but I'm not sure. But basically the static deflection. Because the thing that's going to be the restoring force is just gravity. The reason that this thing doesn't just, you know, throw its weight up this direction and just start floating off that way is because gravity is pulling it back down. Okay? So, gravity acts as a restoring force in this case. So, the way he has omega n figured is g over this is what he calls it, which in my case here I have it as being delta YG, because it's a change in vertical position due to gravity, whatever. I guess this kind of makes sense. Let's see, this is in terms of meters. So meters per second squared. This is in terms of kilograms. This is in terms of it's going to produce an acceleration, so meters per second squared when multiplied by x, which is meters, so it's really just per second squared. I don't know. This is not. I don't know how he figures this. I don't know where these units are coming out of. This is going on my formula sheet because I have no idea why he decided to do this, but I want to make sure I know to do this in the future. So that's the square root of 9.81 meters per second squared over 0.045 meters equals 14.765 meters, excuse me, not meters, per second. And we can call this radians per second because radians have no units really. Because C is effectively 0, zeta is also going to be effectively 0. So I think that this might be just when zeta equals 0. 'Cause, yeah, that doesn't include any damping. So this is only because zeta equals 0. So I need to find the original function for this to put on my formula sheet. Alright, so A equals 0.15 divided by 380 times 14.765 divided by 183.26 squared over the absolute value, which is not going to be an issue because this is way smaller than this value. So this value is going to be less than 1. 14.765 divided by 183.26. This is going to be squared, and then close the absolute value brackets, close the parentheses. So A is 3.973 times 10 to the negative 4th meters, which is correct. Meters is a good unit. These are ratios, so they therefore have no value, or no units. This right here is kilogram meters, 380 kilograms. So these cancel out, and then ultimately the units ultimately become meters. So this is your first answer. This is your answer to part A. Alright, now for part B. B is asking force transmitted to the ground at the same frequency. So force transmitted. This should be pretty easy. We'll just use the transmission ratio. Okay. TR equals F transmitted over F naught. In this case, he's saying that F naught equals ME omega squared. I don't know where he's pulling this from, but this is another thing that's going on my formula sheet. Alright, So we're going to say that